DLN is equal to D log of ASX. So DLN and DLS, that's what we had. So estimate the market model. So what is market model? DLS is the returns from the asset. Market return is DLN. So to get the market model, there's LS, least square. The dependent variable is DLS, followed by C, followed by DLN. This is your market model. Okay, so you are going to do this market model for your assignment as well. Present the actual fitted residual graph and comment on it. So from this output you can find actual fitted residual graph. See here, actual fitted residual. You can choose whether you want to get a graph or a table of value. Okay, I got this from this output, regression output. You can choose view, actual fitted residual, and I'm choosing the graph. The residual curves are what you see here. These are residual curves. And the actual and fitted are at the top. But what you have to find is, for assignment, it's asked only for residual. Right? So from the residual, do you see any pattern here? Do you see every alternate time period is changing its side? It's nothing like that. It is random. Right? It is random. You don't see any pattern here. Or is the error increasing as the time increases? No, you don't see anything like that. Okay, so it is random. If you want only the residual graph, you have it here. You know what I'm showing? The only residual graph. So if you have to get only the residual graph, choose from here. Just to see if the intercept is significantly different from 0. Okay, so let's look at the estimated output. The intercept value is 0.003740. Just because the value is very small, you cannot say it is not significantly different from 0. It all depends on the probability value. You can also use the t-value, but look at the probability value. The probability value is 35.61%. What does that mean? What you want to test is whether beta 0 is significantly different from 0. Right, so here you have beta 0 is 0. But we have got a value, the estimated value, which is 0.00, very, very, very small. Very, very small doesn't, it means that it is somewhere over here. It is somewhere over here such that the area to the right of this one and the corresponding area on the other side, these two areas put together is 35%. That is what the probability value or the p-value means. So P value is equal to 35.61% means that these two areas put together is 35.61%. When will you reject the null hypothesis? You will reject the null hypothesis only if this test statistic is somewhere over here, which is beyond the 5% coverage of the area. But here, the p-value being more than 5% means that you cannot reject the null hypothesis, which is beta 0 is equal to 0, cannot be rejected. Okay, cannot be rejected. So answer based on the probability values saying that the null hypothesis beta 0 is equal to 0 cannot be rejected. Therefore, the intercept is not significantly different from 0. The stock is said to be aggressive. So this is what is related to your assignment. Aggressive if the estimated beta is significantly greater than 1, neutral if it is not different from 1, and passive if it is significantly lower than 1. Use a formal test to decide what kind of stock our work is. Is this what we had expected? Okay. So how do you make conclusion? Look at the p statistic value, which is 4.8, which is high, 4.8. If you have worked with enough of statistic problems, you will know that any p value or z value which is more than 4 is highly significant. Highly significant means that when you draw the graph, the point is far away from the tail end. So what is the area to the right hand side of that point? Is 0. That is what you see as the probability value, 0. So the probability value or p value is less than 5%, the null hypothesis will be rejected. Okay? So here we are testing the null hypothesis. Beta 1 is equal to 0 against the alternative beta 1 not equal to 0. And the p value is 0. So we can say less than 1% or less than 0.1%, right? Instead of saying less than 5%. So 0 is less than, even if you take 0.1 significant term, it's going to be rejected. Therefore, which O is rejected. Significantly different from 0. Do you think multicollinearity could be a problem in this model? So for checking multicollinearity, multicollinearity is only if there is a relationship between independent variables. But here there is only one independent variable, right? So don't talk more about multicollinearity problem for a simple regression model. Just say it is impossible. Finish. Because it's a simple regression model. Right? Multicollinearity is only when there are a number of, or at least 2 independent variables. There is a relationship between those independent variables. Multicollinearity can never be a problem for simple regression model. Oh wait, I think the previous one it has to be tested with 1. I tested with 0. Okay. Sorry, this is not what we are doing. We are checking, I mean question B, we are checking whether the estimated beta is greater than 1 or not. I'll redo this. Number D. So we have to test whether beta 1 is equal to 1. This is your null hypothesis. What is your alternative hypothesis? given that this is the beta value that you have, can you tell me what should be your alternative hypothesis? Yes? Can you take it as greater than 1? No response at all. What should be your alternative hypothesis? I really want to answer. What is beta 1 hat? So in that case, what do you take your alternative hypothesis as?
Less than no. That's right.
I explained that when I explained the assignment questions. I explained it. This is what I said. I'm asking questions based on what I explained here. What is your alternative hypothesis? Is beta 1 hat less than 1 or greater than 1?
Less.
Less than 1. So your alternative hypothesis should be less than 1. Okay.
Less than
So your test statistic T is equal to 0.4796 minus 1 divided by the standard error. The standard error is 0.09986. It's almost 0.1. And the T value is minus 5.204. And if at all you have taken a wrong alternative hypothesis, there is a way to find out that you have made a mistake. But you have to be still careful about it. I'm not asking you to always have this as a rule to check whether you are on the right track. For a left-sided test, if it is conducted sensibly, then your test statistic should be negative. For a right-sided test, if it is conducted sensibly, then your test statistic should be positive. Okay, so this is a highly significant value. So you will have the p-value as equal to 0. Therefore, HO is rejected. HO is rejected, and your beta is significantly less than 1. That means it's passive. Now, as I have the output now, do you have any questions regarding how to draw this kind of graph or anything like that? Any questions on drawing the graph related to your assignment? If you have any doubt on how to draw any of the graph, I have got the data, I have got everything here in eView, I can explain that. At any point, other point of time, if you ask, I'll just say use eView. I cannot show. Now I can show. Any questions? No? If you don't have any questions, we can continue with the small part of topic number 7.